Hi everyone. I'm today going to be talking about LM benchmarking. Not the sexiest topic in the world, but something that I think that should be mentioned because a lot of AI meetups I go to, no one really talks about this. So, how many of you have heard that Gemini 3 just came out? How many? Really? How many of you guys have played with Gemini 3? Decent number. So what I have here is, I don't know if this was published. I found this on Reddit. I think Google took this down for some reason when they launched Gemini 3. But as you can see here, they have highlighted the results and they're comparing it to the previous model 2.5. They're comparing to Claude's latest model, and GPT 5.1. And obviously you see here they do better in almost every single benchmark. I'm curious though, how many of you guys have actually looked into these benchmarks and seen what is the data set or seen what they're measuring? And this is one of the problems that I want to address today. Because I look at this and I think, oh my God, now this is going to be so much better for this task. But it's not necessarily the case whenever I test it practically. So a lot of my discussion today is taken from this paper, Can We Trust AI Benchmarks? And I was reading this paper because so in one of the previous InterSystems AI meetups, I actually talked about how in our team, we built our evaluation framework. And I'm also the type of person who loves reading these benchmarks because I use the benchmarks to inform what model I should use. So I've definitely fallen into this trap. So I want to talk about, this paper goes into 9 different issues with current benchmarks. Some of these are specific to LLMs, but a lot of the issues are actually applicable to AI in general. So the first issue to talk about is data quality problems, and this is a big one. When you actually look at the papers, and if you look at the GitHub repositories where the data sets are, they don't always talk about the data collection process, their annotation or documentation. They're a bit vague about how they came to it. So, for example, there are a bunch of benchmarks that use, for example, are scraping data from Reddit and WikiHow. I might talk about it later in the slides, but one of the subreddits that they look at is "Am I the asshole?" for ethical benchmarking. And I'm not sure if this is I love that subreddit. I'm not sure if that's the best one to be looking for. And then the MMLU, which is a multiple choice based question, a lot of the data is mislabeled. When researchers actually dug into the data set itself, they were as a human completing them, they were 30% of the time, some of these questions were vague. And another fun one, which is applicable to AI in general, is a lot of time models, when they're looking at training data, they might not be looking at the features that you're thinking of. So this is an example from the paper they talk about computer vision problem, where scientists had a bunch of X-ray diagrams, and they were trying to use it to determine collapsed lungs. And then they built a model, and the model got amazing results. Turns out, in the data set that was labeled as collapsed lungs, the models were picking up on the medication that was used to deal with it, than the actual biological features of a failed lung. So, and a lot of time, we're using ML because we're trying to use these models to detect things that our human eye can't. But as a consequence, the models might be picking up on things we don't want them to. And lastly, a lot of these, all these factors in combination sort of lead to this poor answers in the data sets that we're using to evaluate them. And there's not always a lot of validation that goes on to these answers. And I'll talk about a popular benchmark, Truthful QA, which has been cited more than 1,000 times. The good news is, on the latest papers, I don't see anyone use this anymore because people realized that the data set wasn't good, so they changed it and they addressed a lot of its issues. But for a question like this, if you look at answers 1 and 3, they're essentially the same. And it's not a good LLMs are like it's not really evaluating the LLMs because the LLMs might not have this in the training data set, but they might be smart enough to eliminate 1 and 3 because they're like, oh, 1 and 3 are two very similar answers, therefore it can't be those. And then through the process of elimination, it'll pick the right answer, not because it actually knows it. The second thing is issue is construct validity failures. What does this mean? Essentially, what it means is that benchmarks aren't really great ways of measuring what you want to measure. So as if we go over here, you see all these benchmarks, right? They all look at very different things. So we bench verified. AI companies love using this. It's a terrible benchmark, which is used to do agentic coding. You have the MMLU, which is the multilingual Q&A. So all these benchmarks have like different things they're trying to measure, but just because a benchmark says they're measuring it doesn't mean it's actually measuring it, if that makes sense. So for example, like a lot of the times you see in the news that like, oh my God, this new LLM cleared like the step 1, step 2 part of the medical school exams. But that's not what really a doctor does. So you can't really conflate, just a lot of times people conflate because LLM did good in a medical school exam, it means that it would be a good doctor. Not. And a lot of times benchmarks, like safety benchmarks, a lot of times if you look at them, LLM scoring higher on them doesn't mean that it's more safe. In fact, I don't know if you guys saw this, but Anthropic just released a report about how malicious hackers were using Claude code in order to launch a bunch of like, cybersecurity attacks. And like, just because your LLMs are scoring really good in safety doesn't mean they're actually safe. It just means that as models perform better, they will perform better in these safety benchmarks. So, yep, I mentioned here the Reddit MIT asshole used for morals and ethics, and SWE verified. 50% of SWE verified is Django, like Django, the Python framework. I haven't touched Django ever in my life, and I shouldn't be using SWE verified as a benchmark to be like, oh, this model scored better, therefore must be a better coder. And this like construct validity failures leads me to this graph. I love this graph. So essentially what it measures in the x-axis is the measured capacity, so which is what we see like the scores that people publish, and the y-axis is the true capability. Now obviously we don't have a way of measuring the true performance of an LLM, and you'll see these 6 graphs here. What these graphs represent is different ways for us to think about benchmark scores. And what do I mean by that? So I'm going to go back here. So let's take, I love talking about SWE verified, so let's bench verified, so let's take a look at this. If you look at this, you see that, okay, Claude Sonnet 4.5 has a high score. So therefore, it's better than 5.1 and Gemini Pro. But does that mean anything? So what this graph shows us is if you need to start thinking about these scores in terms of like, does it mean that there's like no correlation whatsoever? A higher score doesn't mean a better true capacity? Is it something like a linear graph? Where, so ideally, in an ideal world, our tests would follow a linear relationship with the true capacity. But a lot of times, this is not the case. I frankly think it's something like a sigmoid graph. So those of you with the ML background, you will recognize this. So the idea here is that like from like 0 to 40% of a measured capacity, there's no real difference in the models. It's only when you hit a certain activation point that's actually like, okay, these models are significantly better. So for me, a lot of these benchmarks are like this, where it's like, yes, they're helpful because a difference between 40% and 60% means a lot more than a difference between 60 and 80%. And then there are like other ways that you might think about it. Categorical's sort of similar. I don't think any benchmark is like exponential. But yeah. And this is, I'll see if I can leave a link at the end, but this is from a Substack called Sean Scott. He's a researcher from UCSD. And I was reading his Substack and I was like, whoa, this guy has really, really good ideas about how you think about interpreting these scores. Because it matters. A lot of the issues with the data sets is also the sociocultural context and gap. And what I mean by that is the societal issues, and this by no means relates to LLM benchmarking in general. This is just ever since my undergrad, I've in our class about ethics and ML, we've always talked about like, oh, people of minority being underrepresented in data sets. It's always been a problem. And then it's also primarily based on like Western culture. And this is a problem because like LLMs are very text-based, are obviously trained on large corpus of texts, right? So when you're asking the LLM to make like moral judgments, societal judgments, it's making it based on cultures that it might not be even being applied to. The societal gap is also something interesting, and it sort of relates to the previous point about how benchmarks don't really sometimes address real needs. And so the paper that I was looking at to make this presentation, they were talking about the example of how a lot of medical benchmarks don't really address real needs of like clinicians. And the researchers aren't really talking to the clinicians like, okay, what do you guys care about when we're building this like benchmark and this evaluation? The other one is a narrow diversity in scope. So for example, the scope would be one, how are you actually like evaluating the LLMs? Like you're just using like a multiple choice question. Life isn't really a multiple choice question. And when you're using LLMs, you're not really building it for the use case of, yes, I'm going to use it to cheat on the SATs or something. There are, to be fair, with the first point, there are far more and more tests that are doing like visual-based tests and so forth. So they are becoming more relevant. But this was been an issue for some time. But again, benchmarks for privacy, copyright, and interpretability. Interpretability is a big one. It's like there are a few like chain of thought tests right now that are happening, but they're not really getting at like how interpretable is the conclusion, the reasoning that the LLM came to. I'd also like to add like benchmarking for personalities is not a thing. I'm actually like I think it would be really cool if they like now that with LLMs if they start testing for like how good is an LLM and like having distinct personalities for like depending on a variety of tasks. And a lot of times like they fail to distinguish between noise and signal. So this sort of comes back into like the reproducibility of like your findings. So if you are publishing your stats, you want to be able to test with like different model temperatures, different like seeds that you're setting for the LLM, because just because you got a high score once doesn't mean you're always going to be able to get it. So having others be able to easily reproduce your work is super important. The commercial aspect is like massive. I mean, like whenever people advertise like this new model is like groundbreaking, here's why everyone should start paying us more money. Like there's a lot of pressure to use this, and I don't blame them. And it sort of turns into benchmarking, turns into like a leaderboard. And there's like one or two products out there that like have like a leaderboard thing for like different LLMs or like different tasks, and we're sort of like turning it into a game. Let's see who can get the highest score. And so what sort of happens is that like you start trying to train your model. You're like, okay, I need more data of this type, so my model does really, really well on this benchmark. And it sort of like kills the progress of our model development. And I was actually, I'm curious, how many of you guys know about Bayesian networks? Not a lot of people, or about SVMs. So these are all like areas of research that were kind of killed when like deep neural networks came out. And the reason for that is because these neural networks, and this is way back like in 2014 probably, this is way back when like neural networks started to become super big. So like a lot of this like groundbreaking ideas, like and like very different techniques to like neural networks. Where like researchers stop pursuing them. Why? Because one model will do super well on some benchmark that's not even that good. All the research funding goes towards that, and these like other novel research ideas, they don't receive funding, and so scientists just can't focus on it. Again, this goes back to point 5, but more about the gaming and manipulation. If you try to start achieving high scores on the benchmarks, what you're trying to measure becomes useless. And this is something that I didn't really cover in my previous talk, the AI developers, but I want to talk about. I'll give you guys a bit of context. So we have a system on our team for evaluating our agents. And so we have like 40 questions. We have like a static data set. So we're telling the agent, hey, go to this data set and answer a bunch of these questions. And so when we do at InterSystems, for our benchmarks at least, we don't care about achieving high scores. What we care about achieving more is our agent performing the range of scores we expect it to? Because if it scores better, that's still a concern to us, because we're like, the model is no longer performing the way we expect it to. So we need to check and understand what's changed, and is it good or bad? So this is how I think that we should approach like benchmarks. Like when it performs better, why is it performing better? And then also the data contamination, in the sense that like a lot of researchers will either will unintentionally or intentionally inject the test data used for these benchmarks into the model's training. For example, GPT-4 solving a bunch of easy code force problems before a certain date, because that's when they stopped. That's when the training data went up to. So it wasn't really good at coding. It just had already learned the solutions. And yeah, it's like all these models are being coded, like, because we don't have access to the models' weights for like OpenAI, Anthropic, Google. We don't really know what it's doing. So it's very tough to audit what the model is doing. And then the community vetting is also another issue, because no one really digs deep into a lot of these benchmarks that are being developed, which is a shame. And because you don't get a prize for being like, here's the guy who helps save a bunch of benchmarks. And so it's probably issues that people don't focus, the community as a general doesn't really focus on this as much. And then even when they publish papers about benchmarks, they always focus on the methodology of how they generated it, but not on like the actual content that's inside. And it just comes into the general, like, there are a lot of other good benchmarks out there too, I'm sure. But like the really like for whatever reason, the most popular ones got picked. And then so everyone in the community sticks to it. And this one, like the paper talked about rapid development saturation. I'm honestly, when I was reading this, I wasn't like agreeing with a lot of the points of the authors, but I thought I would explain that's like, and it is interesting, but I just don't think that people went more in depth about these issues. About benchmarks don't really capture the emerging capabilities of models. So a lot of times, like the model, you might have developed a model that actually goes above and beyond what you expected it to. But like if you're not really looking for that, you can't really measure that. And creating benchmarks that keep pace is challenging. But what a lot of good benchmarks are doing now is that every month or two, they'll start changing the data set, which I think is really good, because it's like no way your LLM is going to be trained on this. And then lastly, we don't know issues, right? Like when ChatGPT came out, like the strawberry example, right? Everyone thought ChatGPT was amazing, and then you ask it to count the number of R's in strawberry. Just such a simple problem. But it's like none of these things. How do you even figure out that's something you need to test? And it's like these things are super powerful, but they can be fooled super easily, and that's like a lot of these. That's why a lot of these benchmarks. Yeah, it's kind of difficult to develop them, but they're not testing for things like this. And honestly, like models, like they might be surpassing human understanding, but we're just not really capturing that yet. And this is honestly what I had. So like to conclude this talk, I think benchmarks are important to a certain degree. I don't think benchmarks are as important when someone says they've reached a new high score that's slightly higher than previous models. What they do matter more when they have made significant leaps into problems. They're going from the 40 to 60%. A lot of times is honestly incredible. And if you're looking to evaluate what model to use, I would honestly, if you guys haven't heard of it, you should use OpenRouter. OpenRouter is like a way for you to buy credits, and then you can use any model that's listed there. So some are free to use, some of them are like ChatGPT, like you'll have GPT 5.1, Claude Sonnet 3.5. This is a way for you to not have like 3 different accounts for like 3 different companies, and you just have one account and you can use whatever model you want. So building your own private benchmarks where you test these models on your own. So when I was building this presentation, I just gave the research paper to like both ChatGPT and Claude. It's like, hey, can you develop this presentation? I could do it tomorrow. And like through that experimentation, I found out that Claude sucks at this sort of task, and like ChatGPT is far better. And honestly, like through like figuring out and through like exploring on your own, you will find these things. Yeah, that's my presentation. Any questions?
Sorry, I do have one question. When you talked about the data that the large models use to use the benchmark, right now the humans use a lot of the AI to create text and post on internet and Reddit or etc. And you said that some sources are Reddit. Is there a way or is impact when we test a new model if the data was generated by old model, meaning AI feeding AI and AI and AI?
Yeah, that's a great question, and that definitely does. So interesting you bring that up. What surprised me is if you look at the Quen model series a month or 2 ago, they released like their new models. So what they did is Quen used their biggest parameter model to generate synthetic data that they use to fine-tune their smaller models. So this LLM generating data that is then used to feed other LLMs, some companies and researchers are taking advantage of that. But you are right that this is also a problem because you should have human labeled text and it being AI generated because all the implicit biases that these LLMs are generating, they're getting fed more and more into them, so they're only going to pick it up even more.
Great talk. So, in your opinion, I have 2 questions. So, what is a good way to tackle the unknown unknowns problems or these kind of cases where you don't really know what to benchmark?
I unfortunately don't have a solution. I was trying to look this up myself, and I think one of the biggest things is definitely open source communities. The reason for that is when you are working on this with your team, right? You're going to be very stuck in your own ways. So that more open source development is great because people from very different philosophies are more coming in and like they're bringing in their own like, oh, what if we test with this weird thing, this weird thing? But at the end of the day, I think it's like putting these models out in the public, waiting for people to like find this issue, break it, and then you come back is important. But this is obviously not a satisfying answer because if you're a company trying to develop this, you don't want to use it, but this is like you don't want it to be used in a client production system when something breaks down. But unfortunately, this is true for any software. Like they're still finding. Like I remember, like 3 months ago, like our team had a big Kubernetes. Like there's a new security problem we have to fix this ASAP. This is just the truth of software development.
Right. My second question is about the benchmarks that you mentioned changing every few months. So I would imagine like papers that are published, they would report some accuracy or some performance on those benchmarks. What if those benchmarks change and then you have a different score? Like, how do you keep track of literature that's been published before these changes?
So as far as I'm aware, like obviously they might have to upload revisions to the paper, but a lot of times I don't look at a paper for these benchmarks. I will go to leaderboards for like I forget that I'm blanking on the names of companies, but there are like a few leaderboards. Like I think Ella Marina, that's the one I was thinking of. That's like a dynamic list.
Right, but then the papers themselves will not get republished or reprinted, so it's hard to like evaluate papers that came out.
That's
next
okay.
year.
I think that's okay because I don't think you should be so worried about like if you label in your paper that as of this date these are the scores. That's not like an inaccuracy.
Are you aware of any benchmark that lets us measure our ability to reuse a context? Let me put my question in context. We want to reuse information that we entered, not just in the last several minutes, but say 5 years ago. Say my medical information, my medical chart. And now today I have additional information. I don't want to have to re-enter that entire medical information with the new updated data. I want to be able to say, go look at the context from 5 years ago, and then now reason with this additional information that I have. Is there any benchmark that lets me track the reuse of context, I guess, is my question.
I think there are a few. Let me check this actually. I think I saw this for Google's thing. On the top of my head, I have to say no. I'm sure there's something about context management, but honestly, your problem sounds more like a RAG issue, and I know for sure there are not benchmarks, but at the very least, like metrics that you can calculate yourself using different LLMs about for different like RAG systems. So if you look up something called RAGAS,
If my issue is more, how do I retrieve the earlier context? There doesn't seem to be a database that says, this is my request from 5 years ago. Go look it up and reuse that information plus the additional information. Long term, yeah, that's what I'm at. My greatest frustration is whatever context, whatever questions I asked yesterday, I basically have to start all over the next day. There's no way to store that information and say, can we visit it at a later point in time?
yeah, so there are for sure some memory ones that are sort of based on that. I don't know their names on top of my head, I'm sorry.
I noticed in your graphs, and in all of the graphs except for the random one, there was a positive correlation between what people, thank you, between the measured capability and the true capability. Can you speak to whether in some cases the correlation is positive sum and negative sum, or entirely negative?
That's a very interesting thought. I had not considered that. I think the post that I was reading about didn't cover this. And you're right, it could be a possibility that there is like sometimes going up, sometimes going down. I think in general, it's a decent assumption to say that like there's going to be some increased performance, but that's just based on like this makes me feel good to say like it's an increasing performance. But it's like I think the idea of this graph is less about there's some kind of positive correlation, more about like these are the different potential ways you look between true capacity and measured capacity.
I got one for you too, Jayesh. Looking at these different possible relations between true capacity and measured capacity, if any one of these is true, that tells us a lot about the efficacy of the benchmarks. I know you said we don't know which one of these is accurate, and it probably varies per benchmark. Maybe a way to phrase this is like, how big a grain of salt should we treat the benchmarks? Like when you're evaluating it, do you kind of take it case by case? Do you look for very large improvements in benchmarks? How do you weigh that, knowing it's not perfectly accurate?
I don't say I look for like the difference in the change. Honestly, for a lot of these, what I'll do is, my biggest use for LLMs is coding. So what I will do is I will have some side project I want to work on. So I'm gonna be okay, I'm gonna use Codex versus Claude Code versus one or two other systems, and I'll start using the latest models that they have. A good test would probably be with Cursor with the different LLMs. Use those and see what kind of performance you get for the same questions. So this is when it's unless the performance change is big, the only way to really find out is to test your own particular niche cases that you care for this.
So you have been talking about the benchmarking of LLM here, right?
Yeah.
But there was a question earlier by the gentleman over there about benchmarking agents.
Yeah.
Do you have any thought about that?
Yes, so there are definitely many benchmarks that do agent ones. There's this I think this is Tau Squared benchmark, which is about agentic tool usage. And there are definitely ones that how good is the LLM at memory, and this is the vending machine one, which is if you, I think it's the same user prompt. I don't know if you guys have saw this, but Anthropic had a vending machine they set up that was controlled by one of their LLMs. And it was a very bizarre experiment, but really interesting. But this is the benchmark where it's okay, if you have tools, if you have to plan and do a bunch of tasks yourself, how good is it? So these are benchmarks. My thoughts about them is that they're also kind of helpful. But honestly, I never look at the benchmarks when I'm doing testing an agent. I will literally, at InterSystems, so in our team, what we have done is we have a testing framework for this where we'll run, and we like to run it, well, at least me personally, I like to run a test 15 times. So what I'll do is I will use 3 or 4 different models 15 times, and I will look at their outputs and manually, and I'll be okay, how was it doing the tool calling? How smart was it about doing what I wanted to do?
Any other questions? All right, how about a round of applause for our presenters?